Right, so here's an example of how to use our calculator to do a chi-squared test for either homogeneity or for independence. They work for either one. The setup is exactly the same for each one. So the first thing you're going to do is you're going to go to the matrix, that is blue, and then this one that says blue matrix. And then you're going to go over to edit, use your arrow keys, and we're going to put the observed counts in matrix A. So even if there's already one there before, that's okay. You just press and edit on number 1. And first thing it wants to know is the size. And the size is row first, number of rows, and then number of columns. So in my original count, I can see that there's 2 rows, count today and count 5 years ago. So that's 2 rows. And then columns with data in it. So that's 1, 2, 3, 4, 5, 6. We don't count the total. And then once I do that, it will set up a matrix that should look just like my table. And again, we're not entering in totals. We're only entering in the basic facts within the table itself. So from here, we're just going to type in 9, press enter, and it'll move over to the next cell. And we'll do that until we fill in the entire observed matrix or table. So we got 10 and then a 6, and then we're into the next row, underneath 9 should be 10, and then 11, and then 10, 6, 8, 5, and that should do it. To get out of the matrix, you press second, quit, and we're back out onto the main screen. So now we're going to go run our chi-squared test, and you can do this at the very, very beginning of your write-up for a significance test. And it's going to also help you fill in that second table that you can see on the screen, which is the expected count table. You should still know how to calculate expected counts by hand, but your calculator can do them all for you so you can double check your work. So I'm going to go over to tests. So again, I press stat, then went over to tests. And I'm going to arrow up because I know we're near the bottom of our list now, so it kind of scrolls to the bottom. So there's our goodness of fit one. That's the one that uses lists. We're going to go to chi-squared test. And notice it doesn't ask which type of chi-squared test it is. It doesn't ask if it's homogeneity or if it's independence. And it just wants to know where do I go look for the observed information. So that was matrix A. And then the other matrix is where do you want the computer or the calculator to put the expected values. So I always choose matrix B, and it's okay if there was already previous stuff in matrix B, it will overwrite it when you run this test. So expected matrix is B. And then I can either do calculate or draw. We'll show you both. If I do calculate, it's going to give me my usual stuff that I need for a test. My chi-squared score is 4.0. The p-value is much larger than any alpha level, and it also shows you degree of freedom. However, if I quit out of this and I go back to matrix, so second matrix, you can see that there is now matrix B that is the same size as matrix A. If I go over to edit and go down to matrix B, you can see that these are all the expected counts. These are the same ones that are in the second table down for expected counts. So 10.364, the next one would be 10.364, then a 12, and so on. So you can double check all of your entries here. Last thing I wanted to show you is what happens if you choose draw instead of calculate. So go over to stat test, scroll, chi-squared test. I'm going to use all the same stuff, except instead of calculate, I'm going to say draw. So remember that the chi-squared curve is always skewed right, but it looks a little bit different depending on the degrees of freedom. So you can see that there's already something in y equals. So let me go take that out so it clears that out a little bit better. Looks like I have some kind of stat plot in there. Okay, so let me go and run that one last time. So stat, test, chi-squared test, C. Choose to draw it instead of calculate it. And now it will actually show you what you should be drawing and coloring in. So it shows you that it is a curve that is skewed right and that your line for 4.0 should be just after the top part of that curve and then all the way over to the right. It will still give you the chi-squared score, it'll still give you the p-value, it just won't give you degrees of freedom. So if you want to see degree of freedom to show up on your screen, you'd want to pick the calculate. That's it.